Hi everyone, in this live session we are going to solve this equation which says, the question says how many ordered pairs of integers x comma y satisfy the equation x over 12 equals 12 over y. So you have four choices here, that's 30, 15, 12 or 10. So we have to find how many ordered pairs of integers satisfies this equation. So how would we solve this? How to do this? Let's see. I'm going to write this back. X over 12 is equal to 12 over y. Now that's pretty simple. You would be thinking, yes, let's cross multiply. You're right. So we'll get xy is equal to 12 times 12 is 12 squared. And now, xy is equal to 12 can be written as, we can break it down into 4 times 3, the whole square. Yes, we can write it like this. And now, what do we have? This is in terms of ab whole to the power of x. It can be written as a to the power of x times b to the power of x. So let's split it. So xy is equal to 4 squared times 3 squared. Now what can we do? Now what is 4 squared? We can again split 4 squared. 4 squared is equal to, 4 can be written as 2 squared, the whole square, which is equal to 2 to the power of 4. So we can even write 4 squared as 2 to the power of 4. So let's write it down. xy is equal to 2 to the power of 4 times 3 squared. Now we have got this, but how to find the factors? What is the rule? If you know this rule, you can find any number of factors they have or ordered pairs they can make. Now that's really simple, really easy. What it is you just have to remember this: a to the power of alpha, b to the power of beta, c to the power of gamma, ... and so on, continues. Here a b c should be prime numbers, where a b c are prime numbers. If they are prime numbers, you can apply this. So you can find out number of factors easily. Number of factors is equal to, when you have this condition, number of factors is equal to alpha plus 1 times beta plus 1 times gamma plus 1, and so on, it continues. Alright, so if you remember this, you can easily find out the factors. For example, now let's take an example. For example, if I'm taking 12, so what are the factors of 12? That's 2 squared times 3. Is that right? So I'm going to apply it. So number of factors would be, number of factors for this is equal to, what's the exponent? 2 plus 1 times, what's the exponent? 1. So 1 plus 1. So that is 2 plus 1 is 3 times 1 plus 1 is 2. 3 times 2, 6. So it has total 6 factors. 6 factors of 12. So what are those? 1, 2, 3, 4, 6, and 12. So 12 can be written as product of integers in 6 different ways. 6 different ways. So what are the product of integers? What you can write in 6 different ways? Let's see. So for 12, you can write it as 1 times 12, 2 times 6. Okay, so you can write it as 2 times 6, 3 times 4, 4 times 3, 6 times 2 and 12 times 1. So all the 6 different ways. 1, 2, 3, 4, 5, 6. So you can write the factors in 6 different ways. Now let's write it for this. What do we have? xy is equal to 2 raised to 4 times 3 squared. Let's write down our factors. So how many ordered pairs we have? We just have to calculate the ordered pairs. So we have xy is equal to 2 raised to 4 times 3 squared. So how can we write the number of factors? Number of factors is equal to, what's the exponent? 4. 4 plus 1 times, what's the exponent? 2. 2 plus 1 is equal to, 4 plus 1 is 5. 2 plus 1 is 3. 5 times 3, so that's equal to 15. So you have 15 factors. That means xy can take 15 values and it can also take 15 negative values. So you have xy taking 15 positive values, positive solutions, and xy also taking as 15 negative values or negative solutions. Alright, so that means it has total of how many factors? Like how you have this, 1 times 12. So the other pair is -1, -12, -2, -6, -3, and -4, and so on. Like this, 6 positive factors, 6 negative factors. So we have here how many factors? 15. 15 positive values, 15 negative values. So total how many factors? Total how many values? 15 plus 15, 30. So total you have how many ordered pairs you have? You can have 30. 30. That's your answer. So you need to see the answer choices here we have is 30, 15, 12, and 30. So your answer choice is A. 30 ordered pairs of integers satisfies this equation. So hope this helps. If you have any suggestions, you can write it in the comment box. Thank you so much for joining. Bye bye. Take care.